Space radiation is more hazardous than thought. Implications for astronauts and satellites. University of New Hampshire reports this article March 15, 2018. It might sound like something from a science fiction plot. Astronauts traveling into deep space being bombarded by cosmic rays, but radiation exposure is science fact. As future missions look to travel back to the moon or even to Mars, new research cautions that the exposure of radiation is much higher than previously thought and could have serious implications on both astronauts and satellite technology. In other words, everything in the spacecraft would be affected. Quote, the radiation dose rates from measurements obtained over the last 4 years exceeded trends from previous solar cycles by at least 30%, showing that the radiation environment is getting far more intense, end quote, said Nathan Schwarden, professor of physics and lead author of the study. Quote, these particles' radiation conditions present important environmental factors for space travel and space weather, and must be carefully studied and accounted for in the planning and design for future missions to the Moon, Mars, asteroids, and beyond, end quote. In their study, recently published in the journal Space Weather, the researchers found that large fluxes in galactic cosmic rays, GCR, are rising faster and are on path to exceed any other recorded time in the space age. They also point out that one of the most significant solar energetic particles, SEP events, happened in September of 2017, releasing large doses of radiation that could pose significant risk to both humans and satellites. Unshielded astronauts could experience acute effects like radiation sickness or more serious long-time health issues like cancer and organ damage, including to the heart, brain, and central nervous system. In 2014, Schwadron and his team predicted around a 20% increase in radiation dose rates from one solar minimum to the next. 4 years later, their newest research shows current conditions exceed their predictions by about 10%, bringing it to a total of 30%, showing the radiation environment is worsening even more than expected. Quote, we now know that the radiation environment of deep space that we could send human crews into at this point is quite different compared to that of previous crewed missions to the moon, end quote, says Schwadron. The authors used data from Crater on NASA's Lunar Reconnaissance Orbiter, LRO, lunar observations and other space-based observations shown that GCR radiation doses are rising faster than previously thought. Researchers point to the abnormally long period of the recent quieting of solar activity. In contrast, an active sun has frequent sunspots, which could intensify the sun's magnetic field. That magnetic field is then dragged out through the solar system by the solar wind and deflects galactic cosmic rays away from the solar system and from astronauts in transit. For most of the space age, the sun's activity ebbed and flowed like clockwork in 11-year cycles, with 6 to 8 years lulls in activity, called solar minimum, followed by 2 to 3 year periods when the sun is more active. However, starting around 2006, scientists observed the longest solar minimum and weakest solar activity observed during the space age. Despite this overall reduction, the September 2017 solar eruptions produced episodes of significant solar particle events and associated radiation caused by particle acceleration by successive magnetically well-connected coronal mass ejections. The researchers conclude that the radiation environment continues to pose significant hazards associated both with historically large galactic cosmic ray fluxes and large but isolated SEP events, which will challenge space weather prediction capabilities. The story source is from material provided by University of New Hampshire. This is on Science Daily.